Hello, cosmic traveler. Did you know that there's a planet that could literally be responsible for you being alive today? And here's a question to ponder while you relax. What would happen if Jupiter simply disappeared tomorrow? Throughout this journey, we'll unravel the secrets of this mysterious giant, and at the end, I'll reveal an absolutely fascinating fact about what the Juno mission discovered in the depths of this colossus. So take a deep breath, close your eyes if you want, and let's begin. To understand Jupiter, we first need to grasp its monumental scale. Imagine you could deflate the planet like a giant ball. Now, start placing Earths inside it, one after another. You could fit over 1,300 planets the size of ours before filling all that space. It's like comparing a soccer ball to a grain of sand. But size isn't the only impressive thing about this giant. Jupiter is also the oldest planet in the solar system, while Earth was just beginning to form about 5 billion years ago. Jupiter was already there, floating majestically like a cosmic elder. Its formation happened so early that it played a key role in the fate of all the other planets. Think of Jupiter as the gravitational older brother of the solar system. When you have an older brother, he naturally influences your choices, protects you from some dangers, and sometimes even pushes you away when he's playing. That's exactly what Jupiter did. Its colossal mass and powerful gravitational field shaped the orbits of the smaller planets, determined where they could form, and even ejected some celestial bodies away from the Sun. And here's something that should make you look at Jupiter with gratitude. This gas giant has deflected countless asteroids that would otherwise have been on a collision course with Earth. It's like having a cosmic bodyguard. Over billions of years, Jupiter's gravity has captured or redirected dangerous space rocks, creating a safer environment for life to flourish here. Therefore, many scientists seriously assert that Jupiter was one of the main factors responsible for allowing life to exist on our small blue planet. Without it, Earth could have been bombarded so many times that complex life would never have had the chance to evolve. Now, let's look inside this protective giant. Jupiter isn't made of rocks, mountains, or oceans like Earth. It's composed almost entirely of gas, primarily hydrogen and helium, the very same elements that make up the Sun. It's fascinating to think about. Jupiter and our star are distant chemical relatives. And here's a fact that will leave anyone awake for a few seconds. If Jupiter had accumulated just 80 times more mass during its formation, it would have reached the pressure and temperature necessary to initiate nuclear fusion in its core. In other words, it could have become a star. A small, failed star, but a star nonetheless. Our solar system could have been a binary system, with two suns illuminating the skies. But Jupiter didn't quite make it. It remained a gas giant, spinning through space at breakneck speed. Get ready for this. A day on Jupiter lasts only 9 hours and 56 minutes. That's right, less than a workday on Earth. Despite its colossal size, Jupiter rotates so rapidly that each day passes in the blink of a cosmic eye. This absurd rotation has visible consequences. The centrifugal force caused by this dizzying spin makes Jupiter flatten at the poles and wider at the equator, like a ball of Play-Doh that you spin rapidly in your hands. It is not perfectly round. It is slightly deformed by the very speed of its cosmic dance. And then we come to one of Jupiter's most iconic features, the Great Red Spot. If you've ever seen a picture of Jupiter, you've probably noticed this huge reddish oval on its surface. But what exactly is it? It's a storm. Not just any storm, but the largest known storm in the entire solar system, and it's been raging for at least 350 years, probably much longer. Astronomers have been observing this spot since 1665. Entire generations of humans have been born, lived, and died, and the Great Red Spot has continued to spin tirelessly. To give you an idea of its size, 2 Earths could fit inside it. Imagine the entire surface of our planet. Oceans, continents, everything, and then double that. That's the size of a single storm on Jupiter. And the winds? Inside the Great Red Spot, winds can exceed 432 kilometers per hour, much stronger than any land-based hurricane. The most intense hurricane ever recorded on Earth had winds of about 305 km/h. The Great Red Spot would make that hurricane seem like a gentle breeze. But she is not alone. Jupiter is a world of storms. The planet is surrounded by several other smaller storms that arise, swirl frantically for a few months or years, and then mysteriously disappear. Jupiter's atmosphere is an organized chaos, a violent ballet of winds, clouds, and lightning. Now, let's dive, literally, into the depths of Jupiter. And here's something disturbing. To this day, scientists still don't know for sure if there's a solid core at the center of this gas giant. Think about it. We've sent spacecraft to the moon, landed robots on Mars, even explored the outer reaches of the solar system. But we haven't been able to discover what lies at the heart of Jupiter. The pressures down there are so extreme, so unimaginable, that our best theories are still just well-founded assumptions. What we do know is this. If a core exists, it could be larger than the entire Earth. Imagine a rocky or metallic core buried beneath layers and layers of liquid and gaseous hydrogen, larger than the planet we live on. It's like finding another Earth hidden within an alien gaseous ocean. And things get even stranger as we descend. The pressures inside Jupiter are so absurdly high that they do something extraordinary. They transform ordinary hydrogen into metallic hydrogen, an extremely rare state of matter in the universe. Here on Earth, hydrogen is a light and harmless gas, but compress it to pressures millions of times greater than those at the Earth's surface, and it transforms into something completely different. A glowing liquid that conducts electricity like a metal. It's as if the very nature of matter changes under the crushing weight of that giant. And this metallic hydrogen may be the secret behind one of Jupiter's most powerful phenomena, its colossal magnetic field, the most intense among all the planets in the solar system. Imagine an invisible shield, a gigantic protective bubble stretching across space. Jupiter's magnetic field is so strong that it creates a region around it, called the magnetosphere, that is larger than the Sun itself. If you could see this magnetic field with the naked eye, Jupiter would appear larger in the night sky than the full moon, even though it is much farther away. But this shield has a dark side. Jupiter's magnetosphere captures and accelerates charged particles, creating radiation levels so intense that they would destroy an unprotected spacecraft in minutes. It's a hostile, lethal environment where the planet's own energy manifests as a destructive force. For future astronauts, visiting Jupiter would be like trying to explore the interior of a giant nuclear reactor floating in space. The radiation would fry electronic circuits, damage living cells, and make any manned mission virtually impossible with current technology. And yet, humanity succeeded. The Juno probe, launched by NASA, was specifically designed to survive this hellish environment. Protected by special shielding, it repeatedly flew through the most dangerous region around Jupiter, collecting valuable data that is transforming our understanding of this mysterious giant. We've already mentioned that Jupiter rotates incredibly fast, but it's worth repeating with admiration. This giant completes a rotation in just 9 hours and 56 minutes, making it the planet with the shortest day in the entire solar system. It's as if it's in a hurry, spinning frantically while the other planets move calmly. And this haste has visible consequences. The centrifugal force of this extreme rotation literally molds the planet's body, flattening its poles and stretching its equator, like a pizza being spun in the air by a cosmic Italian chef. But speed isn't Jupiter's only superlative. Its magnetic field is a force of nature that defies imagination. Think of Earth's magnetic field, which is already strong enough to protect us from the solar wind and create the beautiful aurora borealis. Now multiply that force by 20,000. Yes, Jupiter's magnetic field is 20,000 times more powerful than ours. It's an invisible force so colossal that it distorts the very space around it. This immense magnetosphere produces something spectacular. Permanent auroras at the planet's poles, stronger and brighter than any other in the solar system. If you could float above Jupiter's poles, magically protected from deadly radiation, you would see curtains of light dancing eternally in the sky, in shades of blue, green, and red, created by charged particles colliding with the thin upper atmosphere. These auroras are so intense that they could be seen from Earth if Jupiter weren't so far away. And here we return to that protective role we mentioned earlier. Jupiter literally acts as a cosmic vacuum cleaner, its immense gravity deflecting or absorbing asteroids that might otherwise head towards the inner planets, including Earth. It doesn't do this intentionally, of course. It's just pure physics. But the result is the same. A silent guardian keeping the inner solar system a little safer. Returning to the great red spot, that eternal storm we discussed, something curious is happening to it. Astronomers have observed, over the last few decades, that this storm is shrinking. The original red spot may be over 350 years old, but it was once twice as large as it is today. No one knows exactly why. Is it finally losing strength after centuries? Will we see its extinction in our lifetimes? Or perhaps it is cyclical, about to regenerate and grow again. The giant keeps its secrets well guarded. Diving once again into the depths of Jupiter, those extreme pressures we mentioned do something truly extraordinary to matter. The pressure is so absurdly high that it transforms hydrogen, that light gas that floats upwards in party balloons, into metallic hydrogen, a type of material that simply doesn't exist naturally on Earth. You can't create it in any terrestrial laboratory with current technology. We can only produce it for fractions of a second in extreme experiments. But on Jupiter, entire layers, deep oceans of this exotic material exist peacefully under the crushing pressure. And what lies at the center of all this? Jupiter's core remains one of the great mysteries of planetary astronomy. The most recent theories suggest that it may be an extremely dense giant crystal, larger than the entire Earth, where rocks and metals were compressed under such extreme conditions that they formed an ordered structure on a planetary scale. Imagine a diamond the size of a world, buried in the heart of a gas giant. The reality of Jupiter constantly surpasses our science fiction. The storms on Jupiter's visible surface are not only impressive in size, they are violent beyond comprehension. These Jovian storms can produce thunder 1,000 times more powerful than terrestrial thunder. If you could hear one, and survive the experience, it would be like having 1,000 symphony orchestras playing loudly, simultaneously inside your head. The scale of energy released in each electrical discharge is simply astronomical. And here's something fascinating about Jupiter's appearance. Those colorful bands we see, those clouds swirling in hypnotic patterns, are only about 50 kilometers thick. It seems like a lot, but considering they conceal an atmosphere that extends for almost 5,000 kilometers deep within the planet, it's like observing only the thin skin of a gigantic onion. All we see of Jupiter is just the most superficial layer of a world that plunges into impenetrable mysteries. But Jupiter is not alone. It rules its own miniature empire, a system of moons that rivals the entire solar system in complexity. So far, astronomers have confirmed the existence of 75 moons orbiting the giant, and that number continues to grow as increasingly powerful telescopes discover small rocky fragments circulating in the outer regions of its gravitational influence. Among this multitude of satellites, 4 stand out as true worlds in their own right: Io, Europa, Ganymede, and Callisto, the 4 Galilean moons, discovered by Galileo Galilei in 1610, form a system so dynamic and active that scientists sometimes call it a miniature solar system outside the solar system. Each of these moons is unique, with its own geological personality and its own secrets. Io, the closest of the 4 planets to Jupiter, is a world of fire and brimstone. It is the most volcanically active place in the entire solar system, and not by chance. Jupiter's immense gravity literally crushes and stretches Io as it orbits, generating internal heat through a process called tidal heating. Imagine repeatedly squeezing a rubber ball in your hands. It gets warm, right? Now imagine that on a planetary scale, happening continuously for billions of years. The result is a world covered in active volcanoes, lakes of molten lava, and plumes of sulfur that erupt hundreds of kilometers into space. But if Io is a volcanic inferno, Europa is its intriguing opposite, an icy world that hides aquatic secrets. Beneath its frozen, cracked surface, Europa harbors a global liquid ocean with more water than all of Earth's oceans combined. Think about that. More water than exists on our entire planet, hidden beneath the ice of a distant moon. And where there is liquid water, especially water that remains liquid for billions of years, there is the possibility, remote perhaps, but real, of life. Ganymede, the largest moon not only of Jupiter, but of the entire solar system, is even larger than the planet Mercury. And, as if its size weren't impressive enough, Ganymede possesses something extraordinary that no other moon has: its own magnetic field. It is the only known moon that generates an internal magnetic field, like a miniature planet. How is this possible? Probably through a liquid metallic core inside, like Earth, but on a smaller scale. And then there was that fascinating possibility that almost happened. If Jupiter had accumulated just 50 times more mass during its formation, a large number, but not absurdly large on cosmic scales, it would have crossed a critical threshold and become a brown dwarf. A type of failed star that cannot sustain hydrogen fusion, but still glows faintly with residual heat. Our solar system was only 50 Jupiters away from being a binary star system. Destiny sometimes hangs on delicate cosmic scales. The discoveries made by the Juno probe continue to revolutionize our understanding of this giant planet. One of the most surprising revelations was definitively confirming something we already suspected. Jupiter has no solid surface anywhere. There is no ground to land on. If you could plunge through it in a magically indestructible spacecraft, you would traverse increasingly dense layers of gas, then liquid, then exotic states of matter, without ever finding anything you could call a surface. Jupiter is practically a sphere of storms enveloping other layers of progressively stranger states of matter. Another impressive discovery by Juno was mapping the depth of the Great Red Spot. That storm we see on the surface isn't just superficial. It extends 300 kilometers below the visible clouds. To give you an idea, the International Space Station orbits only about 400 kilometers above the Earth's surface. This storm is as deep as the ISS's orbit is high. It's a gigantic column of furious winds plunging into the depths of the planet. And here's something that intrigues scientists. Jupiter emits more heat than it receives from the Sun. It seems impossible, but it's true. It radiates approximately 6 times more energy than it absorbs from sunlight. Where does this extra heat come from? Jupiter is still releasing energy remaining from its formation billions of years ago. It's like an ember that still retains heat long after the fire has gone out. The process of slow and continuous gravitational contraction also generates heat, making this giant a source of energy in itself. Finally, we return to that powerful magnetic shield we mentioned. Jupiter's colossal gravity, combined with its intense magnetic field, creates waves of plasma and radiation so devastatingly intense that they have destroyed several probes that attempted to approach without adequate protection. It is a truly hostile environment, where the planet's own energy manifests as a lethal force for any technology that dares to get too close. Jupiter invites us to admire it from afar, but severely punishes those who approach unprepared. Take another deep breath. Let these images settle. Jupiter, with its deep secrets, its fascinating moons, its eternal storms, and its gravitational dance that protects our small blue world. And speaking of eternal storms, there's something profoundly fascinating about the longevity of these Jovian weather systems. On Earth, hurricanes and tornadoes eventually die out. They make contact with land, lose energy over colder waters, or simply dissipate through friction with the ground. But on Jupiter, there's no solid ground to dissipate that energy. The storms simply continue, fueled by the planet's internal energy, swirling for decades, centuries, perhaps millennia. They are immortal until something more powerful consumes them, or they merge with other storms in a chaotic dance of winds. The Great Red Spot, that storm that has become the iconic symbol of Jupiter, was once even more impressive than it is today. Historical records and ancient observations suggest that it was once so immense that it could swallow 3 Earths at once. 3 entire planets, each with oceans, continents, and billions of people, could fit inside a single storm. It's almost impossible to imagine that scale. And although it has been mysteriously shrinking in recent decades, the spot still has winds exceeding 430 kilometers per hour, maintaining its ferocity even as it diminishes in size. But the Great Red Spot isn't alone in its colorful peculiarity. In 2006, astronomers were surprised to discover a new oval storm that had acquired a similar reddish hue. They affectionately nicknamed it Junior Red Spot, or BA Oval in scientific circles. Most intriguing is that this young storm seems to be growing over the years, as if feeding on the surrounding atmosphere and gaining strength. Are we witnessing the birth of a new secular storm? Perhaps, in a few decades or centuries, junior red spot will rival its older sibling. Observing Jupiter through a telescope, even an amateur can notice something striking: alternating horizontal bands that encircle the entire planet. These atmospheric bands have technical names: zones and belts, and each has a distinct chemical composition and movement patterns. The zones are lighter and consist of cooler ascending gases, while the belts are darker, formed by warmer descending gases. It's like looking at the convection currents of a giant, its atmospheric entrails exposed for the universe to observe. And these bands aren't static. They constantly change, altering in color, thickness, and position over the months and years. Jupiter never looks exactly the same from one year to the next. It's a living planet in the meteorological sense, always transforming, always in motion. Comparing images of Jupiter taken decades apart is like looking at two photographs of a person at very different points in their life. You recognize the essence, but the details have changed profoundly. The planet's extremely rapid rotation amplifies all these phenomena. It creates atmospheric waves and gigantic eddies that can span thousands of kilometers, structures so large that it would take hours to traverse them, even traveling at the speed of sound. And, most surprisingly, smaller storms can form on Jupiter in just a few hours, something absolutely impossible on Earth. Here, it takes days for a low-pressure system to develop into a hurricane. There, the atmosphere reorganizes itself into hurricanes at breakneck speed. We return to that curious fact we mentioned. Jupiter emits more heat than it receives from the Sun. This phenomenon has an elegant name in astrophysics, the Kelvin-Helmholtz mechanism, named after the physicists Lord Kelvin and Hermann von Helmholtz, who described it in the 19th century. The idea is simple but profound. Jupiter's interior is still slowly shrinking under its own gravity, and this contraction process generates heat, just as compressing a gas in a cylinder heats it up. This shrinkage happens on geological timescales, over billions of years. But the heat generated is enough to fuel many of the violent storms we observe on its visible surface. Think of Jupiter as a gigantic cosmic ember, a bonfire that has been burning slowly for billions of years, releasing energy stored since its formation. This internal energy, combined with the solar radiation that hits its upper atmosphere, creates the most complex and violent weather system we know. And what about Jupiter's core, that profound mystery we've already mentioned? The most recent theories suggest it may be a block composed of ice, rock, and heavy metals, weighing up to 20 times the entire mass of Earth. Imagine a core larger and more massive than 20 planets like ours, compressed to unimaginable densities by the crushing pressure of the upper layers. But some theoretical models suggest something even stranger, that this core may be partially dissolved in the ocean of metallic hydrogen that surrounds it, creating a diffuse transition zone where there is no clear boundary between the rocky core and the liquid mantle. It's as if the very distinction between layers dissolves under those extreme conditions. And here's something that should make you rethink the very definition of ocean. Jupiter possesses the largest ocean in the solar system, not of water like the terrestrial oceans we know and love, but of liquid hydrogen, stretching for thousands of kilometers deep within the planet. It's an alien ocean where the waves are formed by currents of dense liquid gas, where there is no surface, where the pressure continuously increases to values that defy comprehension. As we descend through this ocean of hydrogen, the pressures become so absurdly high that they transform the atoms themselves. Hydrogen atoms, each normally consisting of a proton and an orbiting electron, are compressed with such force that electrons are stripped away, creating a sea of free protons and electrons, a state known as metallic hydrogen. It is a material that conducts electricity like copper or silver, but made of hydrogen, the simplest element in the universe. This ocean of exotic liquid metal, swirling rapidly with the planet's rotation, likely acts as a gigantic dynamo, generating Jupiter's colossal magnetic field through complex electromagnetic processes. And going back to that impressive magnetic field, if you could see Jupiter's magnetosphere with your own eyes, if it shone visibly in the spectrum of ordinary light, it would appear larger than the full moon in Earth's night sky, even though Jupiter is hundreds of millions of kilometers away. It's an invisible bubble of magnetic force that extends across a gigantic region of space, capturing charged particles, accelerating them to extreme speeds, and creating spectacular luminous phenomena. These phenomena are Jupiter's auroras, and they are permanently active. Unlike terrestrial auroras, which appear and disappear depending on solar activity, Jupiter's auroras never cease. They are continuously fueled by the planet's intense magnetism, and, interestingly, by the movement of its moon Io. Remember Io, that volcanic world we mentioned? As it orbits through Jupiter's magnetic field, Io ejects tons of particles, mainly sulfur and oxygen, that are captured by the magnetosphere and channeled to the planet's poles, where they collide with the upper atmosphere and create permanent light shows. These auroras are the most powerful in the entire solar system, releasing more energy in a single second than any terrestrial aurora ever recorded has released in entire days. If you could observe them up close, somehow surviving the lethal radiation, you would see gigantic rings of bluish-green light dancing eternally at the poles, luminous curtains stretching for thousands of kilometers, pulsing with an energy that makes Earth's auroras seem like flickering candles in comparison. And this energy that fuels the auroras, storms, and all of Jupiter's atmospheric dynamics comes in large part from the planet's own interior. As we've already mentioned, Jupiter emits more energy than it receives from the Sun, and now we can delve a little deeper into this mystery. The planet's interior is still slowly contracting, billions of years after its formation. It's as if Jupiter is shrinking in extremely slow motion, and this process releases residual heat accumulated over eons. Gravity pulls everything inward, compressing the inner layers, and this compression generates heat through fundamental physical processes. This internal energy is so immense that it drives the extremely strong winds we observe in the atmosphere. While on Earth, winds are primarily driven by solar energy, on Jupiter there is an additional source of power coming from the depths, creating weather systems that defy any terrestrial comparison. And the conditions down there get progressively stranger. Astronomers believe that Jupiter may literally have liquid helium rain in its inner layers, something that doesn't exist on any other known planet. Imagine droplets of liquid helium, heavier than the surrounding hydrogen, falling through gaseous oceans towards the planet's center. It's like an alien rain happening in slow motion through thousands of kilometers of dense atmosphere. As we descend through these layers, the planet's deep atmosphere reaches pressures millions of times greater than Earth's atmospheric pressure at sea level. Under these absurd conditions, the very rules of chemistry begin to change. Common substances like water, ammonia and methane, which on Earth are well-behaved liquids or gases, transform into exotic states of matter. They can become superionic, where atoms form a crystalline structure while ions move freely through it, or assume configurations that only exist in phase diagrams drawn on whiteboards in physics departments. And we return to that impressive characteristic. Jupiter rotates so rapidly that it completes a rotation in just 9 hours and 56 minutes, making it the planet with the shortest day in the entire solar system. This dizzying speed has visible consequences. The centrifugal force literally molds the planet's body, flattening its poles and widening its equator. Jupiter is not a perfect sphere. It is an oblate spheroid, a shape that immediately reveals its frenetic rotation to any attentive observer. Those dark belts and light zones we see striped across Jupiter's visible surface aren't just decorative. They are alternating atmospheric currents, jets of wind that extend for thousands of kilometers in opposite directions, creating turbulent boundaries where storms are constantly born and die. It's like observing Earth's oceans from above, seeing the ocean currents flowing in complex patterns, except here, the currents are made of gas moving at hundreds of kilometers per hour. And the Great Red Spot, that iconic storm we've mentioned so often, continues to surprise and confuse us. At its historical peak, it was so colossal it could have swallowed 3 entire Earths. Today, after decades of mysterious shrinking, it has reduced to approximately 1.5 Earths in diameter. It's still gigantic, obviously, but the question remains: why is it shrinking? Nobody knows for sure. It could be a natural cycle. Perhaps it grows and shrinks over timescales that exceed our observations. Or perhaps we are witnessing the end of a millennia-old cyclone, the slow death of a storm that existed before the Industrial Revolution, before the Renaissance, perhaps even before the fall of Rome. Time will tell. But the Great Red Spot isn't Jupiter's only structural marvel. The Juno probe revealed something absolutely extraordinary when it observed the planet's poles with advanced instruments. Small hexagonal and pentagonal cyclones, arranged in almost artificial geometric patterns. At the South Pole, these cyclones are arranged like a giant flower seen from above, with several vortices swirling around a central cyclone, like storm petals around a turbulent core. What's most surprising is that these cyclones are extraordinarily stable. While you would expect them to merge, destroy each other, or wander chaotically, they behave like fixed blocks of storm, maintaining their relative positions for years. It's as if there are invisible rules organizing these storms into precise patterns, an order emerging from atmospheric chaos. Jupiter's gravitational power extends far beyond its visible atmosphere. Its gravitational field is so intense that it distorts the orbits of asteroids that pass millions of kilometers away. It's like a giant bowling ball placed on an elastic surface, deforming the fabric of space around it and affecting everything that passes nearby. This gravitational power is so great that Jupiter constantly captures small asteroids, making them temporary satellites that orbit the planet for a few months or years before eventually being released back into space, or colliding with one of its moons. And there's something many people don't know. Jupiter has rings, although they are extremely thin and almost invisible compared to Saturn's spectacular rings. These subtle rings are composed mainly of fine dust ejected from its moons when micrometeorites strike them, launching microscopic particles that become trapped in the planet's orbit. They are ghostly, delicate rings, visible only with sensitive instrumentation or when viewed at the correct angle in sunlight. Returning to Jupiter's role as the architect of the solar system, there is growing evidence that it may have been responsible for cleaning up the early solar system in its first few million years. Its immense gravity absorbed or expelled numerous dangerous objects, comets, asteroids, planetesimals, that might otherwise have bombarded the inner planets continuously. Without this gravitational cleanup, it is possible that Earth would have suffered far more frequent and devastating impacts, perhaps preventing the emergence of complex life altogether. That's why some scientists affectionately call Jupiter Earth's protective shield, although this protection isn't perfect. Ironically, Jupiter can sometimes also redirect objects into the inner solar system, like a bodyguard who occasionally nudges you in the wrong direction. The gravitational dynamics are complex and chaotic, but on balance, Jupiter's presence has likely made the inner solar system a safer place. And when a comet or asteroid actually crashes into Jupiter, the impact is spectacular. The most famous event occurred in July 1994, when comet Shoemaker Levy 9, previously fragmented by Jupiter's gravity into 21 pieces, collided with the planet over several days. Each impact released energy equivalent to thousands of nuclear bombs, creating temporary dark scars in the planet's atmosphere that were visible even from amateur telescopes on Earth. It was the first time humanity had witnessed a large-scale cosmic collision in real time, a humble reminder of the violence that permeates the cosmos. But the violence on Jupiter isn't limited to external impacts. Within the planet's atmosphere itself, electrical phenomena of unimaginable magnitude occur. Jupiter's atmosphere harbors thunder so powerful that it can be dozens of times stronger than the loudest thunderclaps ever recorded on Earth. Think of the loudest thunder you've ever heard, the one that made you jump in fright, that rattled windows and echoed for seconds. Now multiply that intensity by 10, by 20, by 50. These Jovian lightning bolts can illuminate entire clouds with monumental electrical discharges, creating internal storms that last for hours, pulsing with electrical energy through atmospheric layers that extend for hundreds of kilometers. And here, we return to that fundamental role that Jupiter plays in our corner of the universe. It acts, in fact, as a shield for Earth, using its colossal gravity to deflect dangerous comets and asteroids that might otherwise be on a collision course with our world. It's difficult to precisely quantify how many objects Jupiter has intercepted over billions of years, but computer models suggest that without this giant guardian, Earth would likely have been hit by far more catastrophic impacts throughout its history. Perhaps life would never have had the chance to evolve beyond simple microbial forms. Perhaps the dinosaurs would have become extinct much sooner by an even more devastating impact. Or perhaps you and I would never have existed. For this reason, some astronomers affectionately call Jupiter the gatekeeper of the solar system. It filters, in a sense, what enters and exits the innermost regions. Its enormous gravitational field also continually shapes the orbits of countless objects in the asteroid belt, that ring of space rocks between Mars and Jupiter. Without Jupiter's gravitational influence, the asteroid belt might have condensed into a planet billions of years ago. Instead, Jupiter has kept that region in perpetual turmoil, preventing the asteroids from coalescing. And Jupiter's gravitational influence even subtly reaches Earth's orbit. Through complex orbital resonances and gravitational perturbations that accumulate over millennia, Jupiter helps ensure the long-term stability of the solar system. It keeps the orbits of the inner planets relatively circular and predictable, preventing orbital chaos that could result in planetary collisions or planets being ejected into interstellar space. But let's return to that fascinating possibility we already mentioned. If Jupiter were only about 10 times more massive than it is, a large number but not impossible on cosmic scales, it could have ignited as a faintly bright star, a brown dwarf emitting faint infrared light. In this alternative scenario, our solar system would have 2 stars, making it a binary system similar to the famous Tatooine from science fiction, where the inhabitants see 2 suns in the sky. What would life be like under 2 suns? Would planetary orbits be stable? Orbital physics would be much more complex, but also potentially fascinating. And here's an intriguing discovery from modern astronomy. Many scientists believe that star systems with hot Jupiters, or massive gas giants, are paradoxically more likely to develop habitable planets in their inner regions. The presence of a gas giant can stabilize the system, clear away dangerous debris, and create favorable conditions for the formation and survival of rocky planets in habitable zones. This means that worlds like ours, with complex life and oceans of liquid water, may be far more common than we imagined in the cosmos. Every star we observe may have its own hidden Jupiter, silently protecting Earth-like planets. The scale of Jupiter's gravitational power is truly astonishing. It is so massive that the point where its gravity equals that of the Sun, the so-called gravitational equilibrium point, or Lagrange point, is located millions of kilometers away. This special region profoundly affects the orbits of space probes, asteroids, and any object that passes nearby. Engineers planning space missions need to meticulously calculate these gravitational influences to ensure their probes follow their desired paths. What if you could, hypothetically, fall inside Jupiter? Well, it would be a short and deadly journey. You would be crushed long before reaching the center. In fact, you would be crushed long before penetrating very deep into the atmosphere. The pressure increases so rapidly as you descend that any object would be compressed, crushed, and vaporized in a matter of minutes. It's like diving into the depths of Earth's ocean, but multiplied by factors of millions. The pressure is literally unimaginable, exceeding anything we can replicate in terrestrial laboratories. And in those absurd depths, that extraordinary phenomenon we've already mentioned occurs. The pressure is so strong that it transforms hydrogen, the lightest and simplest gas in the universe, into liquid metallic hydrogen, an exotic material that conducts electricity like copper, but is made of the most fundamental element. This ocean of metallic hydrogen, spinning rapidly with the planet's rotation, likely acts as a gigantic dynamo, generating through complex electromagnetic processes the powerful magnetic field that surrounds Jupiter like an invisible shield. But what lies at the absolute center? Jupiter's core remains one of the greatest mysteries of modern planetary astronomy. Is it solid, a compact block of rock and metal? Is it liquid, molten under unimaginable pressures? Is it a diffuse mixture, where there is no clear boundary between layers? Nobody knows for sure. The conditions there are so extreme that our best physical theories struggle to make reliable predictions. Missions like Juno are currently trying to decipher this ancient secret. The probe measures tiny gravitational variations as it orbits the planet, and these variations provide clues about the distribution of mass inside. It's like a doctor doing an MRI, but on a planetary scale, trying to see through thousands of kilometers of gas, liquid, and exotic states of matter to reveal what lies hidden at the heart of the giant. Even after decades of intense study, multiple space missions, thousands of hours of telescopic observations, and countless computer simulations, Jupiter continues to surprise the scientific community with phenomena that are not repeated on any other planet. Each new discovery raises new questions. Each mystery solved reveals 3 new mysteries waiting to be explored. And yet, with all its uniqueness, we know that Jupiter is just one example among billions. There are countless Jupiters scattered throughout the galaxy, gas giants orbiting distant stars, each with its own storms, its own magnetic fields, its own moons, its own profound mysteries. Some are larger, some smaller. Some orbit so close to their stars that their atmospheres boil in space. Others wander alone through interstellar space, ejected from their native solar systems and condemned to roam the galaxy for all eternity. And now, we come to that fascinating tidbit I promised to reveal at the beginning of this journey. Are you comfortable? Take a deep breath. This discovery is so surprising that when it was announced, it made waves throughout the entire scientific community. The Juno probe, during its close passes through Jupiter's upper atmosphere, detected something completely unexpected: lightning occurring at the planet's poles. For decades, scientists assumed that lightning on Jupiter, as on Earth, occurred mainly in equatorial regions, where the atmosphere is warmer and convection is more intense. But Juno revealed that the story is much more complex. Jupiter's poles, those cold and seemingly calm regions, are teeming with intense electrical activity. And these aren't just occasional lightning strikes. We're talking about massive electrical storms occurring in regions where traditional atmospheric physics suggested they shouldn't exist. This has forced scientists to completely rethink their models of how Jupiter's atmosphere functions at high latitudes. But there's more. Juno also detected something called sprites and gnomes, transient, luminous phenomena that occur high above storm clouds. On Earth, these rare events have only been photographed in recent decades and are still poorly understood. Discovering them on Jupiter was like finding a familiar phenomenon on an alien world, suggesting that atmospheric physics may be more universal than we thought. And the most unsettling discovery of all, Juno measured natural radio waves emanating from Jupiter and discovered signatures suggesting the presence of water surfaces. Not outer oceans, but deep layers in the atmosphere where pressure and temperature transform water vapor into liquid droplets or even ice, creating water clouds, so dense they behave almost like suspended atmospheric oceans. These water layers can extend hundreds of kilometers deep, hidden beneath the visible clouds of ammonia and methane that we observe. Think about this while closing your eyes. Somewhere in the depths of Jupiter, there may exist suspended oceans of water, pressed down by atmospheres so dense that the distinction between liquid and gas becomes meaningless. Jupiter, this giant that has protected us for billions of years, still holds secrets that we have only begun to unravel. So, the next time you look at the night sky and spot that bright point, Jupiter is usually the fourth brightest object in the sky after the Sun, the Moon, and Venus. Remember all that it represents: a silent guardian, a gravitational shield, a world of eternal storms and exotic oceans, a mystery shrouded in layers of gases and secrets. Good evening, cosmic traveler. may your dreams be as vast as Jupiter itself.